In this video, we're going to learn how to balance chemical equations. Here's a typical question that you would get in chemistry when you're first learning how to balance. What you need to know already is the law of conservation of mass, which basically states that the mass of reactants equals the mass of products. Reactants are found on the left-hand side of the arrow, and products are found on the right. You start with a certain amount of atoms, and you should finish with that exact same amount and type of atom. If we draw the Lewis structures of water and all our products, which is hydrogen gas and oxygen gas, you can see that you have a certain amount of atoms that you're starting with on the left side, or the reactant side, and you can see that you're finishing with a certain amount of atoms on the product side. If we add up our hydrogen atoms on the reactant side, we can see that we have 2 atoms of hydrogen, and we have 1 atom of oxygen. On the product side, we can see that we have 2 hydrogens and we have 2 oxygens. This breaks the law of conservation of mass because there is a good amount of hydrogens. You start and finish with the same amount, but the oxygens, there is less that you're starting with compared to what you finish with. So we have to balance, and this is the purpose of balancing right now. To fix this oxygen problem, we need to have more oxygens on the reactant side. Now you might want to just put a little 2 here, which is a subscript, so it says H2O2, but that's wrong. And the reason why it is wrong is because you are changing water to H2O2. Instead, what we have to do is we have to keep the water molecule intact. Don't change the subscript and put a 2 in front of the H2O. That means that we're going to have 2 waters instead of just 1. Now this is great because it solves our oxygen problem. You can see that I have 1 oxygen, 2 oxygens, and now I have 2 oxygens, which matches up with the product side, 2 oxygens. But you'll also notice that I've changed the amount of hydrogens that we have here. I now have 4 hydrogens on my reactant side. On the product side, you can see I only have 1, 2. So to fix that, we are going to put a 2 here. And that is going to change the amount of hydrogens that we have. And you now can see that I have 4 hydrogens on both sides. This is the purpose of balancing. It basically shows you that you have 2 waters reacting to form 2 H2 molecules. This is one, this is the other. There's 2 H2 molecules, and there is 1 O2 molecules. The coefficient, or the numbers in front, tell you how many you have. Now keep in mind, you do not put a 1. Instead, you just leave it as a blank and you assume it is a 1 there. So I'm going to give you some harder examples. Here we have a chemical reaction number 2, and what I want you to remember is you can't change the subscript, you can only change the coefficients. So how many H's do we have on the left? 2. How many do we have on the right? 1. How many sulfurs on the left? 1. How many on the right? 3. How many AS on the left? 1. How many AS on the right? 2. So we are just adding up, and we're looking at the subscripts right now, and we're comparing on both sides of the arrow, on the reactant side, product side. This can be summarized like this. Okay, so what you want to do is you want to balance this out. To do that, we're going to change coefficients, not subscripts. I'm going to show you a way, and oftentimes you got to play around with it a little bit. There is tricks of the trade. You want to pick the one that is the least common atom or least common ion. That's a general thing. You want to balance polyatomic ions if they have them there. Here I have no polyatomic ions, so I can start wherever I want. Generally, if it's difficult to balance and you get stuck, just start over and go quickly. So for example, from experience, I know I'm going to balance sulfur here first because I have 1 and 3. So I have 3 on this side, I have 1 on this side. To change that, I'm going to put a coefficient of 3 in front, and it will multiply in times the subscript, and it will end up being 3. So I balance my sulfur, but in the process, I've also changed the amount of hydrogens I have there. I now have 6 hydrogens. So again, if I had 3 of these, you would see clearly I have 6 hydrogens. Now I've also changed the sulfurs, I've balanced that out. Let's take a look at our count again. Hydrogen is now messed up, so I'm going to try and fix my hydrogen here. I'm going to put a 6 here. That means that I have 6 H's, and I also have 6 Cl's. If I drew out 6 HCl's, you would see that I have 6 chlorines on there as well. So my chlorine is now 6. Now you can see that I've created a new problem. This chlorine is not matching this chlorine, so I'm going to put a 2 here. And now I have 6 chlorines, because this multiplies by this. But you'll also see that I've changed the arsenic so it has 2. Now if we look at our numbers, we are all balanced and we are done. Okay, so I'm going to balance number 5 for you now as well. And this one is interesting because I can see that I have an element here, but then I have an ionic compound. And it's really important that you did your chemistry work before this and you can identify polyatomic ions. And I'm going to count nitrogen and oxygen together in a nitrate molecule. Okay, so when we count nitrates, we can see that we have 2 nitrates. This number outside of the bracket there tells you how many nitrates you have. And you look on the other side, you can see that you have 2 nitrates as well. I like to keep track of my charge there as well. That's a -1 charge. Well, how many zincs do we have on the reactant side? Well, we can see that we have 1. How many zincs on the product side? We can see that we have 1. How many leads on the reactant side? 1. How many leads on the product side? 1. So if I look at this, this is balanced. It's good to go. That's it. Okay, here's an example that's going to be a little bit more difficult. We look at this and we see that we have a metal and a non-metal, and we have a metal and a non-metal, and then the same thing kind of repeats on the other side, metal, non-metal. I also recognize that I have a polyatomic ion, so I'm going to count polyatomic ions. We have a reactant side, we have a product side. We're just going to add up and see how many we have of each. I have 1 sodium on this side, I have 1 sodium on this side, 1 lead on the left-hand side, 1 lead on the right side, 1 iodide on the left-hand side, and 2 iodides on this side. So I'm automatically seeing that one. That's one I'm going to have to balance. And I can count my nitrates. So how many NO3s do I have? Listen to my words carefully. I have 2 nitrates, or 2 NO3s. How many NO3s do I have on the right side, or product side? Oftentimes students will say, oh, you have 3. You don't. You have to identify that as a nitrate and NO3. You have just one of them. You'd have a bracket if you had more than one. So you can identify that the iodides and the nitrates are not balanced, and we're going to balance those first. It doesn't matter which one you pick. It's because iodide's up top above nitrate in my list here. I'm going to do iodide. So I'm going to put a 2 here. Reminder, you can't change subscripts, so I couldn't write 2 down there because that would mess up the charge balance between sodium and iodide. I have 2 sodium iodides. That means I have a 2 here, and I also have 2 iodides. So that means my iodides are in check, and now I've created a new problem. My sodiums are not in check. So I'm going to fix my sodium problem. I'm going to put a 2 here now. It multiplies in. I have 2 sodiums, and I have 2 nitrates. And now when you look, you can see that we have 2, 2, 2, 1, 1, 2, 2, 2, 2. We are balanced. This is good to go. That is a double displacement reaction. We'll talk about that more later. We can tell because it's got 2 ions that are switching partners.